Foundation level, objective 4.3.2, K2. Explain branch testing. First question. Which of the following statements about branch testing is correct? A. If a program includes only unconditional branches, then 100% branch coverage can be achieved without executing any test cases. How can we achieve any coverage without executing any test cases? This is nonsense. B. If the test cases exercise all unconditional branches in the code, then 100% branch coverage is achieved. If we cover only all the conditional branches, that means we haven't covered any conditional branches. So there's no guarantee that we have achieved 100% branch coverage. C. If 100% statement coverage is achieved, then 100% branch coverage is also achieved. Oh, we have talked a lot about this already. 100% statement coverage doesn't guarantee 100% branch coverage. This is wrong. D. If 100% branch coverage is achieved, then all decision outcomes in each decision statement in the code are exercised. This is correct. 100% branch coverage means that we have covered all conditional and unconditional branches. Each decision outcome corresponds to a conditional branch. So 100% branch coverage implies 100% decision coverage. The correct answer is D. Second question. Which of the following statements best describes the difference between decision table testing and branch testing? This should be an easy one. Decision table testing is a black box technique, while branch testing is a white box technique. A. In decision table testing, the test cases are derived from the decision statements in the code. This is incorrect. Test cases from decision table testing are derived from the specification. Let's move on. B. In decision table testing, the test cases are derived from the specification that describes the business logic. So far, this is correct. In branch testing, the test cases are based on anticipation of potential defects in the source code. This is incorrect. In branch testing, the test cases are derived from knowledge of the control flow of the test object. Anticipation of potential defects is used in error guessing, which is an experience-based technique. C. In decision table testing, the test cases are derived from knowledge of the control flow of the test object. Again, this is incorrect. D. In decision table testing, the test cases are independent of how the software is implemented. In branch testing, test cases can be created only after the design or implementation of the code. This is correct. Decision table testing is a black box testing method, which means that it looks at how the test object behaves without looking at how it is implemented. Because of this, the test cases don't depend on how the program is built. Branch testing is a white box testing method, which means that test cases are based on the analysis of the test object structure. Because the test cases depend on how the software is designed and coded, they can't be made until the test object has been developed or implemented. Third question. Let the branch coverage metric be defined as branch coverage equals X divided by Y multiplied by 100%. What do X and Y represent in this formula? We know that the formula for calculating branch coverage is the percentage of the number of branches exercised by our test cases divided by the total number of branches in the code. A. X. Number of decision outcomes exercised by the test cases. Y equals total number of decision outcomes in the code. Decision outcome means we consider only conditional branches. This is incorrect as X and Y are supposed to consider the number of total branches in the code, whether conditional or unconditional. B. X equals the number of conditional branches exercised by the test cases. Y equals total number of branches in the code. This is incorrect as X is supposed to be the number of the exercised branches in the code, whether conditional or unconditional. C. X equals the number of branches exercised by the test cases. Y equals total number of branches in the code. This is correct. D. X equals the number of conditional branches exercised by the test cases. Y equals total number of decision outcomes in the code. Again, this is incorrect as X and Y are supposed to consider both conditional or unconditional branches. The correct answer is C. Fourth question. You want to apply branch testing to the code represented by the following control flow graph. How many coverage items do you need to test? Well, this question is new to me. The syllabus didn't mention the edges anywhere. From the modal answer, we learned that in branch testing, the coverage items are branches, which are represented by the edges or the arrows of a control flow graph. From the graph, we have 8 arrows. So according to the modal answer, the correct answer is C. Now, this is a very controversial question. I have never seen any book or website that calculates the branches using the edges. All books consider the branches as conditional branches only. Most professors I know didn't have a clear-cut answer on this. I had a very long conversation with ChatGPT, and it didn't agree with the answer as well. If we consider conditional branches only, the answer would be 4, considering the nodes that have more than one output arrow, each one representing either true or false. So I am not convinced with the model answer to this question.